This graph here, fun fact, fun one. We'll learn about that later, maybe. So obviously, if you drew a vertical line test on here, it passes at 2 spots, right? And so we know if anything passes at for one particular value of x, we have 2 y's, and so we know that that's not a function, right? Sorry, I don't mean to write that. We'll say fails vertical line test. Okay, and then we saw this graph. Some of this is a little expectation that you know what these graphs look like, but we know that this is the V, right? And passes. So if I drew vertical lines on this for all of every domain, I'm going to get 1 unique y. Okay, so that's going to be a function. Okay, and x equals 6. A little tricky. Do we know what x equals 6 looks like? What's it look like? It's a vertical line. Okay, so every value, if I drew a grid and this was 6, every value along this line is going to have an x value of 6. That's what that means. Okay, so it fails the vertical line test. Okay? Down here's a little function notation for you just to see whether or not you could like interpret what function notation was doing. Okay, and so for this one, f of 0 means to plug in 0 for x. Okay, and so when I plug in 0 for x, I'll try to go fast on the questions that don't need me to go slow. Okay, 0, 0, so f at 0 is going to equal -8. Okay, f at -3, that might require a little bit more work just in terms of calculations. That's going to equal, just plug it in, -2 times -3 squared plus 4 times -3 minus 8. Okay. Sorry, what did I do wrong?
3 times -3.
Oh, my question's different. You have 3 on your page?
Yes. 3 on.
Oh. I changed it to a 4. I must have. That's our. Is it a 4 or a 3?
Yeah, it's a 4.
We have 4s and 3s? Oh, it's just 3 on mine. Okay. Sorry, my bad. No, it's not. Is it really? Oh, no. We're talking about this here, right here.
Oh.
This one.
Oh, yeah.
Sorry, I think I changed it after I dropped it on my iPad. I changed it to make the question work out nicer numerically. It was a 3, and then I changed it so that it worked out better. Okay. I think I changed it to a 4 for everybody, right? Okay. Scared me. Okay. What really scared me is something about 4s and others 3s. That was weird. I don't know how that's possible. Anyway, so we're going to get -2 times 9 minus 12 minus 8, right? And so we're going to get -18 minus 12 minus 8 should be what? -38. Does that seem right? Okay. I changed it to a 4 because of this question. It made it work nicer, just mathematically. Okay. Again, my intention is not to make you sit here and do silly fractional work. It's more just to test the concept of function notation. So I changed the equation. I must have just forgotten to switch it here. Okay. F of 2a is going to be -2 times 2a squared plus 4 times 2a minus 8. Okay. Now you would have done, because I did it with my grade 9s, some exponent law or power law stuff, right? That squared has to go onto both things inside of that bracket. Okay, so we're going to get -2 times 4a squared. And remember, I know I'm doing it that order because I'm following BEDMAS. Okay, where exponents come before the multiplication and division. Okay, so I distributed that exponent into the inside of the brackets, and then I got 4a squared. Plus, now you can distribute that out to be 8a minus 8. Okay, and now you could go like this. Are we happy? That'll be what the value of 2a is, or f of 2a. Evaluating f of x when x is 2a. Okay? Any questions? I know I went a little quick there. You threw me off. You ruined my pace with the 3 and 4 conversation. Okay? What happens if we evaluate when f is at a half, or a value of half? I'm going to get f at 1. Yes, sorry, yeah.
Wouldn't you be able to just, I think I did this somewhere, wouldn't you be able to just combine negative 8a and 8a? Oh, okay, never mind.
Yeah, just be careful, okay? Don't worry if you run into that issue, don't worry about it. We're going to do more of that later when we get into the quadratic stuff, but you can't, this is like adding apples and oranges together, right? You can't do it. They're different, okay? So they just stay that way. They're two kind of separate kinds of terms, okay? I'd imagine in grade 9, somebody would have showed you what they actually look like with the algebra tiles, right? Have we worked with algebra tiles before? Some of us? No? Okay, we'll do that. I'll show them to you, and then you won't make that mistake ever, okay? We'll do that later. Okay? Same thing here. We're going to get negative 2, but we're going to plug in a half for x this time. Okay, everybody agree? Same idea with the power, though. That squared has to go to everything, both numerator and denominator. Okay, and this is, I think, this is why I changed that 3 to be a 4 for this particular question. Works out nice. Okay, we get negative 2 times 1 over 4. Okay, square the top and square the bottom, okay, of the fraction. Plus, so we can do the multiplication there. That's going to be 4 over 2, and then minus 8. Okay, so we get, did I do that right? Oh yeah, I did do it right. Okay. So we're going to get negative 2 by 4 plus 4 by 2 minus 8. Again, I don't think you need to show all this work if you don't need to. This actually didn't work out as intended. I thought it was going to, but it didn't. You could take care of this first if you'd like. I was writing bigger. I thought I had more room. Okay, we could go 2 minus 8 is going to be negative 6. Okay, and you could do the common denominators if you'd like. Well, what should the answer be? I'm okay with this, I think. Yes?
How many of those steps do you need?
I don't, honestly, you guys show the number of steps. Just, okay, so here's the conversation we have around this. You show as many steps as you need to show, but if there's something, like if you get a final answer wrong, and there's no work there to support where you went wrong, I'm under the assumption that you did something wrong somewhere. I can't give you part marks. I think the more stuff you show, albeit this is overkill, I think. I would agree that this is overkill. You don't need all that. But I think the more work you show, it just gives me more stuff to give you part marks for. In the event something went wrong, you got the wrong answer. Okay, so if you feel confident enough in your answers, just write it down. Okay. Are we okay with that? Guys, that's just function notation and evaluating things. Evaluating things with function notation. Plugging in values of x, which you've done before, it just looks a little different. Okay. Now, this question here was a little unintentionally difficult, but it's all right. I'll show you. I didn't mean for it to be this way. I made a little error in my head. But it worked out. The question's fine. There's nothing wrong with the question. Okay? So when you look at this, I want to know what this is saying. I want to say, what is y when x equals 2? So you go find x equals 2. That's right here. And you look up. What value do you see? Okay, what value of y? Remember, y is on the vertical axis. What would you say that is? I know the exact answer, but I'd be okay, yeah?
Like 1.4?
Okay, yeah, that's 1.41 is the exact answer. But I would have, my intention with this question was just for you to be able to like read off values of y with x. So I would have taken 1.5. We'll go back in a second and figure out exactly how to figure out the actual answers. I was a little worried when I saw this question. I was like, oh, I asked you an unfair question, but then I was like, it actually worked out better. Okay, and I'll show you how in a sec. Okay, for this one here, what's the y value when x equals 0? Go find x equals 0 and read off. What's the value? 0, it's right here. Okay, so that's 0. Okay, and then this is where I realized I went, uh-oh, I did a little wrong thing here. This is like, what is x when y equals 9? Does your graph, the way I've graphed it, ever reach 9? No. I don't know why I did. So be careful. It can happen to the best of us. I think you can flip-flop in your mind. Like I was just redoing the other two questions and like expecting to do that, but that's not what it asked. It wants to know, what's the value of x when y is 9? Well, you're going to be there. That's going to be a pretty big picture that I can't fit on the piece of paper for this particular question. But, so I had a little moment of freak out, but then I thought, it's not impossible, is it? What's this graph? What is this function? We've already looked at this. Yeah?
Y equals the square root of 5.
Or yeah, so it's g of x or y equals the root of x. That's the hook function, right? We already saw this. Right? And so if I was looking for, remember we could write this y equals root x too, that's okay. Okay? We want to find what is x when y equals 9. Does everybody agree? So just plug in y equals 9 and solve for x. Which it worked out that you had this skill. Right? So we're going to say, okay, 9 equals root x. Does everybody agree? Yes, no? This is the function of the graph, right? This is like function of the graph. This is the function that has been graphed. It's root x. It's y equals root x. So if I ask you, what is the value of x when y equals 9? Well, how would you solve for x here? It's square rooted on the right. If you were solving for x, what would you do to get rid of that square root? What's the opposite of square rooting something? Harriet? No?
Exponent.
Exponent to the power of what, though? 2.
Square.
Squaring it. So the opposite of square rooting is squaring, right? So I could take this and square both sides. And I would see, okay, x equals 81. Little unfair of a question. And this is why we do this. But not really, because you had the skills to do that. Because did you or did you not do that investigation in 1.4? You should have. So you should have known what that function was. Okay? I got lucky. You didn't. You didn't get lucky. All right? Now, the reason why I was okay with the 1.5, you could do the same thing and figure out this the exact value here. And it turns out when you do this exact same math, it's 1.41. That's the value of the function right here. It's just a bit below 1.5. Oh, sorry. Don't write it like that. Goodness me. Okay? Everybody see what I'm saying? I'll make it a nicer question on the test. I won't do it. That's why we do this. Okay? Both for you to get familiar with what I'm going to ask you, but also to make sure that I don't make that mistake on a summative and then freak everybody out. Okay? So now I won't do that. Okay? Domain and range. Okay? Does anybody know what this shape's called? Just out of curiosity?
Oval?
An oval, or is specific in scientific terms? Yeah?
No. Never mind.
No, that's right. That's right.
An ellipse?
It's an ellipse. Right? This is like
ellipse is dot, dot, dot.
is it? Oh, I don't know. I'm going to call it an ellipse. Here's the sun, and here's the earth.
Yeah.
Okay? Anyway. Domain. What values of x are sufficient or valid for this particular graph? You can say it can take on any value of x ever as long as those values of x stay within -5 and +5. Right? So we could say, okay, it can take on any value of x as a part of the real numbers such that as long as they stay between -5 less than or equal to x less than or equal to 5. Okay, and the range is basically the exact same. It's just that different, because it's not a circle this time. It can also take on any value of r, or y, sorry, as long as it stays between okay?
Just out of curiosity, do you need to use the variables x and y? Like, does it matter? Because it's like a set value.
Yeah, I mean,
Is that just for clarity?
I just used, yeah, I think domain is typically x and range is typically y. I think if you had a graph of something else, like let's say, distance time, then you might choose to use, just make sure you're keeping it consistent with the independent variable goes with the domain and the dependent variable goes with the range. I think that's what matters, okay? So in that instance, I'd say t is a part of the real numbers such that it stays within, okay? Time doesn't really make sense there because you got -t, but anyway, you get the idea, okay? Then on the other one, we've got our friend the hook graph again, or the root x, okay? And we could say, okay, the domain, it can take on any values of x such that as long as x is greater than or equal to -2. Okay? And then the range, take on any value such that y is greater than or equal to -1. Okay? Questions, comments, concerns? The last one is just to test your little like grade 9 fractional skills, dealing with fractions, maybe without calculators if you wanted to. Okay? Okay, so remember what we said with A. If you have the division, you treat the numerators as a separate entity from the denominator and follow BEDMAS accordingly, okay? Okay, so then in the numerator, we're going to take care of the multiplication that exists there. So I'm going to see 10 plus 56 over 6 plus 5. So we get 66 over 11. 66 divided by 11 we know as being 6. Okay? Now in the next one for B, okay, just before everybody gets caught up, I did ask, and maybe I forgot to mention this, I asked Ms. Farahani about, remember we were talking about whether or not we could shuffle things around? IB doesn't really care, so you're okay to do that. So I did this solution like that, okay? I wasn't sure if you're going to lose 4 marks for like switching fractions around. I didn't really think you would, but I just wanted to clarify. So what we can do here, I mean, right off the bat, if you had your calculator available to you, you could just do this, I suppose. Just multiply all 3 tops and all 3 bottoms. But what if you didn't have a calculator? Because there are going to be portions of your IB exams that like, there's going to be like part A, part B, where there's no calculator permitted, and then there are calculators permitted for part B. And what they'll do is they'll say, here's booklet 1, no calculators, nobody's allowed to have a calculator on their desk. You hand in booklet 1, and then you get booklet 2. That's how they work it, okay? So there are going to be instances where you might not necessarily be able just to type stuff into the calculator. So it might be a good idea to have some coping mechanisms in those instances, okay? So for this is why I mentioned this, I shuffled some things around. Okay, so I rewrote this question to look like this. Okay, I don't necessarily need the multiplication signs in the middle, but Okay, and then multiplied by negative 25 by 15. It really shouldn't matter because it doesn't matter the order of the order of multiplication in either the numerator or the denominator, right? You just multiply. Okay, and so now you could do a little reduction. Well, I know 6 over 36 is going to be negative 1/6. I left the 12 over 15 for a sec. And I knew 25 divided by 15 I could reduce to, oh, what did I do? Sorry. 25, sorry. What did I do? I had the top right. What did I do? Oh, sorry, it's a 5 here. There you go. Sorry, I got it. I was like, my solution matches, but what I wrote on the page didn't. So then you get negative 5 by 1. Okay? And I left it by divide by 1, so we're still comparing all the fractions, right? So then I saw, and again, I'm if you had a calculator, this wouldn't be an issue. But if you didn't, just want to make sure you're good. Okay? So I said, okay, well, I'll group these two. I have negative 1 by 1. I'm going to multiply that by 12 by 6 and negative 5 by negative 15. So I get negative 1 times 2 times 1/3. Ever see what I did? That's if you didn't have your calculator. If you had your calculator, I just go like this. 1800 over 2700, or to be negative, sorry, which you could reduce to that. Depends whether or not you got your calculator, right? But I think the last thing we want is for you to have that crutch of the calculator all the time and not be able to do something like that, like a workaround, okay? So just try and practice that as you go through like grade 10. Just try to try questions without using a calculator and see if you can do it, okay? Okay, and the last one is just but just testing your ability to multiply by a reciprocal. Okay, so we'd say negative 13 by 4 divided by 2 by negative 3, which we know as being three by 2. Multiply them, so you can get 39 by 8 should be your. Okay? Any questions?